Hello, and welcome to Amplify's 3.5 for Metabolism. Today we're going to look at modeling cellular respiration in an athlete's body. It's important to look at this because we've already compared what a healthy body looks like to unhealthy bodies. So now we're going to use that baseline of a healthy body to see how athletes have to train to affect their own body so that they can process more nutrients and become stronger and faster than most people. We're going to begin with all lessons like we do with the warm-up. But before we do, you'll notice that we're starting with 3.5. And if you go back to the chapter, we haven't yet done 3.4 for blood doping. Don't worry about this lesson. We're going to come back to it later because it's mostly a reading lesson, and I want you to keep working on what you already know before going back to the reading. If you really are interested in this lesson in order to stay on track, you can go ahead and read it in section 4. But today, you're not required to do it, so there won't be a video on it, and you'll be able to skip it. If you want to know more about it, you can pick the videos for the lesson 3.4 and see what that's about. But today, we only need to worry about 3.5. So let's get started like we usually do with the warm-up. In the warm-up, we're going to make predictions about how an athlete's body will differ from a normal healthy body in the sim. So in the warm-up, we need to take a look at what they're asking us to do. We're going to run a test in the sim in the next activity to compare a normal healthy body to an athlete's body. We're going to make a prediction of what you will see in comparison and explain our reasoning. So again, this is a big part of science, making predictions to find out what will happen. This is called hypothesizing. I've talked about it a bunch, but I want you to become familiar with the vocabulary. When we hypothesize, we make a prediction or a guess and give a reason for why we think it might happen. A simple example is if you held a ball in your hand and dropped it, in other words, let go of it while it's facing down, I would hypothesize that the ball would fall to the floor. And we could predict that it would fall to the floor because we've seen it happen before. That's my reasoning. I've seen it happen before. And when we test it, it will happen every time. That's science. Having a hypothesis, proving if it's correct, and then seeing if that result comes up every time. So let's go ahead and try that now. So oxygen molecules taken per breath. The athlete's result will be higher than normal, lower than, or the same as. In my opinion, I think an athlete will take in more oxygen than normal. So I'm going to put higher than normal. For my reasoning, I'm going to type in why I think this is. I think the athlete will use more energy than a normal healthy body. So normally, a lot of us would stop right here and think that's good enough. But remember, you need to be super clear when you're giving evidence in science. I think the athlete will use more energy than a normal healthy body might be true, but it has little to do with why the oxygen is there. Or if it does have something to do with it, it's not really explained in this answer. So let's correct this answer so that it has the full explanation. This is because it requires, let's spell correctly. It requires oxygen to make more energy. So it will have more energy than a normal, healthy body. Alright, so now my answer is fully fleshed out because I've given what I think will happen, which is that the athlete will use more energy than a normal body, and I've explained why that is with reference to the question I'm being asked. Many times we'll give answers that are simply like this, and it's not enough because it doesn't really answer the question that's being asked. In this case, the question that's being asked is, oxygen molecules taken in for breath will be higher in an athlete. But why is that? And I've written why. Remember to answer those questions. Alright, I want you to now practice this same thing with part 2 and part 3. You want to know whether the oxygen molecules absorbed by cells in the athlete's body will be higher. You want to know whether the higher cellular respiration will change. And you want to make sure that you explain your reasoning for both of them. Remember that this answer I've written here may not necessarily be correct. It's an answer I've just written to show you how to pick out these boxes, how to explain your reasoning. So be sure you use the sim to find out. You can do that by clicking up here, by scrolling up to the top, clicking on these 3 little bars, and then clicking on the metabolism sim. When you do that, you'll get the sim like this, and you can pick a healthy body and an athlete's body. Let's go ahead and begin the level athlete, just so I can show you how you would find these figures. I'm going to observe this body and pause it for a second. Remember, you're going to be looking for 3 things. The first is, the athlete's results will be higher than normal for the oxygen molecules taken per breath. You can find those in the graph just like we did when we looked for Elisa's results. Right here, oxygen taken in per breath. In this case, it's 40 molecules. You can then look at oxygen molecules absorbed by the cell, which you can see here, total molecules absorbed by the cell. The easiest way to test this one would simply be to make sure that you test them for the same amount of time. For example, I've been for 1 time unit. If I feed this person a fish, a corn, and a sandwich, and I wait for 20 time units, so I'll go ahead and speed it up a little bit. I'll wait till it's 20 time, and I'll pause it. And then I check how much they've absorbed in the graph section. I can see they've absorbed 29 oxygen molecules in their cells. Now I can go back and test the healthy body and see which is higher in order to answer this question. For this one, the cellular respiration level, I can go ahead and check that by checking out the cellular respiration here, this figure. If I want to look at just this figure, the easiest way to do that, we need to blink them all away. And I can see here, at the beginning it gets pretty low over 20 time units. That might be different from how it works in a regular body, so I'll have to conduct a few tests and check these graphs to see which of them is higher on the graph. You can even see they mark it here, highest, lowest. So the higher it is, the more cellular respiration there is. The lower it is, the less there is. So I can look at this graph and see if it's higher than on a graph of a healthy body. Once you've done those things, and you've figured out your answers and made your guesses, you'll be ready to move on to the second part, the sim, comparing a healthy body to an athlete's body. Before you do that, make sure you click the hand in button so that I can grade your work and give you the points you deserve. And then we'll get ready to move on to step 2. I'll see you in the next video.